Hey everyone, welcome back again. Today we're going to be working on a 4L60E. Unlike my other 4L60E video, which was largely stock or factory level build, this one's going to be the polar opposite of that. It's going to be geared up toward high performance. So excited about this one because we're going to be doing a lot of different things that we would do for even a mild or moderate performance build. Some of the parts that are going into this thing, I mean, we're talking like beefed up to the extreme. So if you're about to embark on like a high performance build, maybe you're doing like a resto mod or a muscle car or something like that, or you're just modifying an existing vehicle that takes a 4L60 or 65, one of those transmissions, 700R4, this would be a really good video in particular to give you an idea of what to consider for part selection and build procedures and things that you would do differently in a high performance application that you would not do in a stock or mild build type situation. So we're going to be throwing pretty much everything but the kitchen sink at this thing, and like I don't even know what the kitchen sink would be equivalent to, because everything that's going in this transmission is going to be designed to handle a lot of power and a lot of RPM. So kind of sparing no expense with this build. It's going to be going into quite an interesting vehicle, in fact, a 1930s Ford coupe. And the coupe will be powered by a 650 plus horsepower LS1 or LS6, and the owner's going to use it primarily to cruise around. I mean, that's going to be what most everybody does, and even in a street strip application. But he's also going to have fun with it, which means taking to the track on Friday nights and some spirited driving around town. Of course, he's not going to break any laws. No one would ever do that. But the goal here is to give him a transmission that will kind of thrive in that high intensity environment. So I'll walk you through all the different parts that we're going to be installing and the rationalization behind it, give you some tips and tricks for rebuild, for reassembly, some things to take into account. And then I'm not going to do a literal step-by-step build like I did with the other 4L60E video, because other than the procedures that are different that make this build, different, if you will, from a process perspective, that I'll show in its entirety. But like things like the installation of bushings, setting up the reverse input drum, some of the case assembly we're probably not going to show, just because again it's the same as the other 4L60E video. But I want to focus on part selection primarily, at least in this segment, so that you have an understanding of like what we're doing and why, and you can kind of equate that to what you're working on, or what you want to learn more about. All right, so let's take a closer look at all the parts. Okay, the first area we'll focus on when it comes to high performance and comparing, contrasting that, procedures and parts that we would install here versus a factory build is going to be the pump assembly, heart of the transmission. So for all high performance builds, it's absolutely critical that you start off with fresh, flat, and true surfaces on the pump cover and the pump body. So machine both deck surfaces square and true, and then make sure you have the pump body's pocket here cut, machined, milled, however you want to say it, relative to your rotor and your slide. The rotor and the slide clearances for high performance have to be within factory specified ranges. So for the rotor, it's going to be 1.5 to 2.5 thousandths clearance between the top of this rotor and the deck surface. This rotor is upside down, so it would be this side compared to this side, and you would check that with a straight edge. The slide needs to be between 2 and 3 thousandths clearance. So I have a separate video on how to check this, but it's it's very simple. You just take your straight edge with some feeler gauges. You sit the rotor and the slide into the pump body. Leave the support O-ring and the support off of the slide. Leave the rotor guide and the pump rings out, just dry rotor by itself, and then measure with feeler gauges. Generally, you're either going to give your machinist the rotor and the slide along with your 2 pump halves, or the machinist is going to acquire a new rotor and slide kit for you so that he can machine the pump body such that those clearances are met. All right, the next thing you want to do is install a set of transgo and breakable pump rings. So these are ductile iron rings, and it comes with an updated priming spring for the slide. This will stabilize the rotor slide movement at high RPM, prevent deflection and such. And at the same token, it will also ensure that you don't have a failure at the rings. The factory rings are fine for pretty much almost any application except for extreme performance, extreme duty situations. So I always like to install this unbreakable pump ring kit. Transgo makes these for this transmission. I know we're obviously working a 700R4, and there's also a like-kind kit for the 6L family of transmissions, and essentially anything where the type of pump is a vane style and where these types of rings are used. Third thing you want to do is use an updated, or I should say upgraded, bushing in the rear of the stator from Sonnax. Factory bushings, again, are fine for factory applications, but I like these coated bushings for anything high performance. And the same goes true for the pump body. All these different Sonnax parts that you see come out of the SureCure kit, so pump and valve body, as well as the accumulators, see upgrades from that kit. You also want to upgrade the hydraulics, so here we have the Sonnax boost valve, which I install in all my 4L60E builds, along with the spring that comes with the kit, and that increases baseline pressure linearly by roughly 10% over factory. You also have an updated or improved torque converter lockup valve. So that comes with a late model spring. It's, again, a late model style. And it also comes with a Teflon sealing ring that goes right here in the groove. So, just like that. Obviously it goes, on it, but that's where it goes. Okay, new pump vanes. Always install new pump vanes. New Teflon rings. Last thing I'll mention is the drain back. You want to bore the drain back port out to 5/16 of an inch. So what I'll do is I'll go in with a 1/4 inch drill bit and kind of get it started, and then I'll follow it up with the 5/16 bit. I find that that's a little bit easier, and it also makes for a nicer looking cut, a nicer looking bore. It's up to you if you want to do it that way or not. It doesn't really matter, I guess. So that's the pump. I'm trying to think if there's anything else I need to cover about it. And I think we're good. As far as like other parts, I mean, always replace your electronics, your soft parts, consumables. The spacer plate, I'll cover hole sizes for your clutch feed and exhaust ports and solenoid balance ports. Once we get to the point where we're gonna install it back onto the transmission case. Bolts and small parts. So that's the pump. Now I'll talk about some of the updates we're going to do with the valve body, the servos, and the accumulators. Okay, with respect to the valve body in these transmissions, there's really not a whole lot that you would do to recalibrate shift firmness. All of the mods that you would do to a 4L60E valve body in any application, really, not just high performance, are mostly corrective in nature. So in other words, corrective and to improve functionality. So the one mod that I recommend everybody do for any 4L60E from 93 to around middle of 06, late 06, is going to be changing the mechanical apply for the torque converter clutch from a pulse width modulated apply strategy, in other words PWM, to an on-off strategy. So if you look at your pump assemblies for these transmissions, anything 95 and above is going to have the letters PWM cast into the front of the pump. So that indicates that it is a pulse width modulated design intended to be used with a torque converter clutch apply strategy that uses pulse width modulation. Now, pulse width modulation, in other words, in layman's terms anyway, is a gradual apply of the torque converter clutch. It's not an on-off. What that does is it builds a little bit more heat, and it's basically a designed-in slip intended to allow for like a smoother engagement of the converter and in later model units, and this is why I said mid to late '06, it also plays a key role in facilitating the variable valve timing and or active cylinder management that went into these vehicles around that time frame. So what we're doing here is we're just going to be using two small little check balls and the factory spring and installing these two check balls on either end, and when this goes into the bore, this valve is stopped from moving completely, so that effectively converts it from a PWM to an on-off apply or regulation strategy, I should say. You can use a Fitz-all valve here. Fitz-all is a company that makes things like corrective TCC regulator valves for 4L60Es. They also make spacer plate repair kits and a variety of other different things that you can use to repair or remediate different parts inside the transmission. So that valve has O-rings and it completely seals off that bore, and it also resolves trouble code P1870, the late harsh 1-2 shift, if in fact the late harsh 1-2 shift is caused by a worn TCC regulator bore, which in these transmissions is very common, especially between years 95 to 2000. In 01 and up, it's not as common. It can occur, but not nearly as prevalent as it was in that prior vintage. There's O-rings on some of the bore plugs in here, so these are the Sonnax bore plugs. The actuator feed limit valve, we're installing a dual spring setup, so the spring that is inboard or on the inside comes from the kit. We're also going to run with pinless accumulators, so the forward accumulator has two check balls. That's for plugging the bore here. All right. Otherwise, you'd have a massive leak in the forward apply circuit from the hole location where the pin was. You just pull the pin out. For the 1-2 accumulator, the 1-2 is going to come with two different check balls. You're going to use one of these based on whether you have a large hole 1-2 accumulator or a small hole 1-2 accumulator. Most of the 4L60Es are small hole. So again, same deal. You would have a massive leak here in the forward accumulation, the 1-2 accumulation circuit if you did not install that check ball to block it off. And then you just install the spring kit from Sonnax. For the 3-4, there is no check balls because it's essentially a blind hole. There's no area per se or no location for fluid to just hemorrhage out of that apply circuit. So the pin is a blind hole location. Once you pull the pin out, you just put the spring in and then the piston, and that's it. All these pistons take both a rubber seal and a Teflon seal. All right, so that's valve body, that's the accumulators. Let's talk about the servo. We're going to be using a Sonnax Superhold servo assembly kit for both the second and the fourth gear apply. Depending on your application, you could do one or the other. If you're doing a lot of heavy towing and hauling, it's also recommended you use a second and a fourth gear, but you can default to just a second because you really shouldn't be towing in overdrive. In other words, you shouldn't be towing heavy loads in fourth gear anyway. So assuming you engage the tow mode and or you just simply manually place the vehicle into drive 3, a second gear servo, like a Sonnax Superhold or the Superior Tech equivalent, or one of the other ones on the market, will be sufficient. In a high performance application, especially a street driven vehicle, it is a good idea to install a fourth gear apply servo. Now again, when you're racing, you should not be in overdrive for a variety of reasons. But so if in a pure race situation, believe it or not, if you just went with the second gear servo, then that would probably be fine. And when I say race, I'm talking drag racing, quarter mile, eighth mile, maybe half mile. You're not going to be in overdrive. Now, if you're doing, circle track or you're doing road racing or whatever, you may be in overdrive. If that's kind of in the cards, then I would recommend a fourth gear super servo. So the Sonnax second gear servo has a significantly greater amount of apply area than does the factory Corvette servo. Generally speaking, all other things equal, the more surface area for apply fluid on a given servo piston that you have, the firmer your shifts will be. So if you did nothing else to this transmission, you built it factory, you know, you didn't change the size of the feed holes in the separator plate, you didn't install any kind of shift kit or do anything else, you know, all you did was install like a super servo, then your shifts from 1 to 2, assuming we're talking about the second gear servo, will be noticeably firmer than they were when compared to when the factory second gear servo was installed. And that could be a 553 servo, which is the standard servo for most GM vehicles that took V8 and larger V6 engines, or the Corvette servo, which went into obviously Corvettes, F-bodies, and certain high-end submodels of trucks and SUVs. So that's valve body, that's servo, that's accumulators. I'm going to move the camera down a little bit further on the bench and we'll talk about clutches and particularly the forward drum. Okay, start off by talking about the friction module that we're going to be using in this transmission. So everything is going to be Alto high energy frictions throughout the transmission. We're also going to be using a Alto Kevlar line band for the 2.4 band. The reverse input drum itself, other than the upgraded frictions, is not going to see any modifications. If you're installing a Transgo shift kit and that kit comes with little restrictors for the reverse input drum piston, I would strongly advise you not install them. The way that the factory designed that piston for all 4L60Es is perfectly fine. For any application, it does not need modification. New bushings in the drum, new bushings everywhere in the transmission. That's pretty much standard fare. So that's all that really needs to be said about the reverse input drum. Other than that, you want to make sure that that drum is perfectly flat. So when I build something that's going to take aftermarket servo assembly, then I prefer to actually take a good used drum and machine it. And that's because I'm going to need a little bit more clearance owing to the fact that these pins are going to be a little bit longer for those kits that come with pins than the factory pins. You still may have to grind down on the tip of it a little bit, but if you machine the drum, say 0.010 of an inch, that might kind of alleviate the need to grind, or at least reduce the amount of grinding you have to do to the pin. So again, that's the extent of the discussion that needs to be had on the reverse input drum and clutch pack. For the forward drum, so we are going to be running a Sonnax Smart Tech drum in this transmission. In my opinion, it is the best forward drum on the market available for these transmissions, so 700R4, 4L60Es. The drum is heavily modified and reinforced relative to a factory drum, and it uses a hardened heavy-duty input shaft. So let me grab it and I'll kind of show you what I mean if you're not familiar with these or you haven't seen one kind of up close before. All right, so one of the areas that's improved is the inner stator here. All right, that's heavily reinforced with the reinforcement kit from Sonnax. Now, you can purchase the reinforcement kit separately if you don't want to spend the amount of money that it's going to take to acquire this drum. The kit's considerably less money, and it does a nice job of reinforcing and strengthening a factory drum and input shaft assembly for heavy-duty use or moderate street strip applications. For really extreme duty or where power levels are going to exceed, say, 550, 600 horsepower, this is strongly recommended. And it's one of those deals where you just have to pay to play. These things are over $1,000 in most cases, $1,000 shipped, but it's worth it. So they come in all different varieties. There's drums with the shafts for the LS Gen 3 small blocks. There's ones that come equipped with the little reluctor gear for the later models that took that input speed sensor. And then there's also ones that are available for 700R4s and early 4L60Es that use a 298mm design. The other major difference between this drum and all the factory drums is how the 3.4 clutch pack is set up. So you'll notice right away that there are there's no snap ring groove. The drum eliminates the 3.4 clutch snap ring and replaces it with a bolt-on apply plate. I should say backing plate. This is the backing plate. The other thing's the apply plate. So it uses 15 different little fasteners. They all get torqued to 55 inch-pounds. And this drum is designed to accept 7 friction 6 steel stack up using factory 4L60E 3/4 clutches and steels. In other words, not the 4L65s that use thinner clutches and steels to achieve that 7 clutch stack up, but regular 80 thou thick clutches and 110 thou thick steel. So it's makes for a significantly stronger clutch pack relative to even the 4L65 or 70E transmissions. So both the ply plate and backing plate are choline steel treated. So in other words, they got that choline coating on them. So here's the 3/4 stack up. All right, this is generally what I'm going to be doing. I say generally because I actually don't know what the stack up will look like until I start, putting it together. It may not be exactly what you see there. It may be, 1 clutch less, 1 clutch more. I may have to swap in a thinner clutch to make clearance, or I may do something different. But generally speaking, for high performance, you want choline steels in both the 3/4 clutch pack as well as your overruns or coast clutch. Okay, and the reason for that is the assumption for any kind of high performance street strip is there's going to be some burnouts happening. So when you want to do burnouts, you need to be in manual low, or at least start, and then gradually upshift as you cycle through your burnout. So you want choline steels in the coast clutch area because those clutches are going to be involved, and you're going to be using those clutches in more frequently, more often than in a factory type use case. All right, we're not doing anything different with the pressure plates themselves for the forward and the overrun. Standard fare. So the reinforcement kit that comes from Sonnax, whether it's part of this drum or independent, comes with the Sonnax coast clutch piston. So you have to use this piston if you're going to run that reinforcement kit, or you're going to run this drum. It's a billet aluminum piston, no issues with it whatsoever, and it is substituted in place of the factory molded steel and rubber piston. The other 2 pistons, they don't see modification. You just install them as you normally would. Okay, anytime we're doing anything high RPM, you always want to install these high rate return springs. These will go in the 3/4 return spring assembly as well as the forward return spring assembly. So that's this forward and coast clutch. You have to install both sets. You can't install one or the other. I mean, you'll never be able to get the assembly in if you try to install, say, only the 3/4 springs. It's not overly difficult or tedious to swap the springs out, at least not in these transmissions. That kit will work for 700R4s, 4L60Es, 4L65, 4L70. The 4L80E equivalent springs are a pain, especially the direct drum. This kit also contains a little bleeder valve that replaces the factory bleeder valve. So even the Sonnax drums come with this factory valve, or ball capsule, I should say. I don't know if you could see that, but the reason why these drums come with those and not the improved version from Transgo is simply because the Smart Tech drum can be used in any application, and in an overwhelming majority of the types of use cases, types of environments, you don't need to install that modified bleeder valve. But high performance, again, all these things you're doing, bleeder valve, high rate return springs are really to prevent centrifugal apply. I mean, that's the primary purpose for making these changes. Now, the high rate return springs also have the added benefit of improving your 3/2 downshift, making it nice and crisp, all other things equal. So again, it's one of those deals where if you do nothing else but change out the return springs, then your 2/3 shift and your 3/2 shift should be crisper. All right, as far as the other 2 pistons, I recommend you just stick with the OEM stuff. All these molded rubber pistons, bonded pistons, whatever you want to call them, are all made by National Seal Company. That's where GM gets them. So I know there's some blue stuff that's out there on the market, where the pistons are blue in color. I think some of them are made overseas. I can't sit here and tell you that they're problematic. I don't know. They just started appearing on the market recently, but I always default to the OEM stuff. All right, forward sprag assembly or input sprag assembly. Always replace your one-way sprag clutches in all builds, not just high performance. Forward sun gear, you can make little notches like this. Just cut little grooves in the top of the sun gear, and this can be done in any transmission. And that will promote a little bit more fluid flow to the planetaries, especially at higher RPM. So it's a good mod to make. Doesn't take very long to do. And then for your outer race on the inner surface that works with the sprag itself, 400 grit sandpaper. Just go over it, a bunch of times to reintroduce the cross hatching, and that'll give a better surface for the sprag to bite into and hold. All right, let me move this camera down just a little bit, and then we'll talk about the back half of the transmission and wrap up. All right, given the power levels, the customer is elected to install or have installed a billet steel output shaft. These are always recommended anytime you go above 600 horse. I'd say maybe 550 to 600 horsepower, and where the transmission is going to see a lot of hard launches, you want to make sure that you reinforce that output shaft. The factory one can snap in in situations where you're pushing out that much power. Otherwise, it's not really necessary. These are very, very expensive. I think I want to say like $500-600, something like that, maybe more, depending upon which one you get. But it is recommended for when power levels, are above that, like 550 to 600 horsepower range, and the application is racing, or the vehicle is going to be raced at least once or twice. We have to install a factory reluctor gear for the speed sensor, so we'll do that. 5-pinion front and rear planets. These are genuine GM OEM planets out of a 4L65E core that I personally tore down. So I pulled these planets from the transmission. I didn't buy them off the shelf, so I know for a fact that's where they came from, and they are genuine OEM. For the rear sun gear, I recommend you install a wide sun gear bushing. See if you can get that into focus. I'm gonna probably start installing that bushing on every build. I mean, it just makes sense. The factory bushings are about half to maybe 2/3 as wide, and I can't tell you how many of these transmissions, these in 700R4s that I've torn down, where that bushing is either in the process of walking out or has walked out. Under high RPMs, it's almost a certainty. It's not a matter of if, it's a matter of when, and it's going to happen sooner rather than later. So you install this wide bushing here, and then you put Loctite so that it stays put, and you won't have any issues with that bushing walking. So here's the reaction shaft. I mean, that fits like a glove, and it feels perfect. Just enough clearance to allow lubrication oil to flow through. So the reaction shaft itself is going to be from a 4L70E. It's got the surface here, the step for the bearing. So the major difference between this reaction shaft and all others prior to it is the induction hardened splines here. The 4L70Es are the only transmissions that took this shaft. The 65s didn't have them. This was an update that GM made for the 4L70E starting, I believe, in 2007. The 4L65Es were in production from 2001 to 2006. Their RPO code is M32, and the 4L70Es, the RPO code or regular production order code is M70, and you can find that code for your transmission, your vehicle, in the sticker inside the glove box. All right, Sonnax Smart Shell, again, best sun shell on the market, in my humble opinion. The shell comes with a heavily reinforced set of splines in the spline area. This is where the shell will fail in the factory and some of the aftermarket hardened heat-treated units. I've seen some of them come in, broken. And this will not break, this will not fail. The splines are heavily heat treated. You have a billet steel reinforcement plate here, and then you have heat treated engagement lugs where the shell mates with the reverse input drum. The shell also comes with an updated center support inner race for the low roller clutch and a bearing. So between the reaction shaft bearing and this bearing, we've rollerized the middle of the case completely. New low sprag, or I should say low roller clutch for the center support. The low roller clutch is only holding on takeoff, so in first gear. Once you upshift to second gear, doesn't matter if you're, what range you're in, the sprag starts to freewheel. In other words, it's not holding anymore. So these are rarely bad. And in a factory transmission, factory build, stock or mild, updates to the engine, you really don't need to replace it. It's a very, very low failure rate part. In fact, I think I want to say I've seen maybe 6 or 7 come in with failed low roller clutches. And this is over, I'd say about 600, 700 R4s and 4L60Es that I've built over the course of, all my years of doing this, roughly 10 years now. So very low failure rate item, but again, high performance, they're not expensive. I'd rather just restart the clock at 0 with that part. So it's just, one more area where we can de-risk. All right, bearings are soaking. Nothing different about the low reverse, just same factory sealing rings, same factory return spring and snap ring, nothing different. So tubular steels, always run tubular steels in your reverse input and your low reverse for anything high performance, from 700 R4 through early 4L60Es. Just retro back the steels. I mean, they'll be fine. You can certainly add choline steels, to my knowledge. At least I haven't come across a set, so maybe some of you are familiar with a set that where there's choline heat-treated steels offered of the tubular variety, because that's what I would prefer. I'd rather have the tubular steels here that allow for more fluid flow and keeping the clutch packs cooler relative to the steels that don't have those cutouts than the choline, because low reverse is going to be on for burnout, but unless there's something wrong with your seals, you're not going to burn up the low reverse clutch pack, assuming everything else in the transmission has been done right, and you're not doing something that you shouldn't be. What we have here is a set of end play washers. Now, Sonnax makes 2 different end play shims. This set is actually for the rear ring gear. So it may not be as well known, but you can adjust end play in 2 different places in this transmission. And when I say end play, I mean front end play. That's the only end play you're going to measure, but you can adjust it via shims that go underneath the selective spacer that sits in the pocket underneath the forward drum thrust bearing, or you can adjust it via these shims that go under the output thrust bearing here on the ring gear journal. So if you ever find yourself in a situation where you've built up a 700R4 or 4L60E, you go to install the pump, and either the pump won't seat fully, or when you do seat it and you torque up your bolts, you got your gasket installed, there's 0 end play, and when you did your check, when it came in and it had plenty of end play, and you didn't replace anything, then you may want to consider that you installed the rear thrust bearing, meaning the thrust bearing that goes here on the ring gear, upside down. If you install that thrust bearing upside down, it's going to move the entire guts of this transmission toward the pump by, I want to say, about 20 to 30 thousandths of an inch, somewhere in there. It's pretty significant. It may be 15 thousandths. It's somewhere in that general neighborhood. And I know this because I've done it by accident. And, you know, I was putting together 4L60E, I think it was like a 95 or 96. This was, I'm now going back like 8-9 years ago when I first started building these. And I got to the pump and I installed the pump, and it just felt a little bit weird, almost like it was bound up. And of course it was. I couldn't spin the input shaft at all. The input shaft was seized. So I couldn't figure out why that was happening. And, you know, I didn't actually replace anything other than the sun shell. Like, all the other hard parts were in good shape. The drums were in good shape. And, you know, I was kind of at a loss. So I had torn down the transmission, going back through, you know, methodically, piece by piece, section by section, until I got to the rear and I saw the bearing. I mean, luckily the bearing happened to fall off the ring gear. And I immediately realized that it was upside down. And I didn't even know that that, you know, would have had anything to do with my problem. But I corrected it, flipped it right side up, and reinstalled everything. And sure enough, I had about 15 thousandths or so of end play when everything went back together. And I realized, well, yeah, that was the problem. So anyway, long story short, you can use these shims. You can use shims for the forward drum. You want to adjust your front end play so that you have between 10 and 20 thousandths at most end play on a high performance build. I like to be between 10 and 15. I want that case to be nice and tight. I do not want any slop, if I can help it at all, between any of the components, particularly between the the reverse input drum and the pump. So I think that covers everything I want to cover. If you have any questions, comments, go ahead and leave them below. If there's anything else that you do to a 4L60E that I didn't include here, you know, please post as to what that is. I mean, like I said, I'm here to share my knowledge, but I'm also here to learn. So, you know, it's great when we can all share best practices and, you know, help each other improve our builds. And, you know, ultimately, if we're doing this for, you know, for a business, improve our customers' experience. So I'll film the assembly of the forward drum, the servo, and then the assembly of the case. But I'm probably not going to film the pump assembly because procedurally everything is identical. I mean, I may film it, or I may just, you know, kind of insert portions of it, but I don't want this video series to be super long. I really want this video in particular to kind of be a standalone, as, like, you know, more of a consultation and overview video versus in a procedural assembly how-to type video when it comes to high performance, because procedurally everything is largely the same except for the areas that I mentioned. You know, the forward drum assembly, that's going to be significantly different, so we'll film that. The servo, setting up the servo, and then checking the servo travel and band clearance, that's going to be a little bit different, so we'll cover that, take you through step by step there. But everything else is going to be pretty much the same. You know, I'll film a little bit of the case assembly and whatnot maybe, but beyond that, you know, I think that we'll kind of wrap it. So as always, thank you so much for watching. I appreciate your time, appreciate your, you know, your views, your likes, your comments, you know, any feedback, and you know, really appreciate you, you know, spending time on my channel. Until the next video, have a great rest of your day or evening, and we'll chat soon.